Hi, good morning to everyone. So today we are discussing the topic is current electricity. In this, the next topic is the electric cell. What is meant by an electric cell? Electric cell is a device which converts chemical energy into an electrical energy. The cell which converts chemical energy into an electric energy. So in this type we have two types of electric cells. One is the primary cell and second one is the secondary cell. Okay, primary cells cannot be charged again. Okay, that means the cells are used and throw it. That means they are not used for again charging the cells. That means primary cells cannot be charged again. Voltaic, Daniel and lattice cells are primary cells. Okay, next one is the secondary cells. Secondary cells can be charged again and again. Acid and alkali accumulators are secondary cells, are the examples of alkali and the acid cells are the examples of secondary cells. Okay, cells is a device which converts chemical energy into an, so cells lo emuntundama chemical energy, it will be converted into electrical energy. That device is nothing but a electrical cells. We have two different types of cells. Charged batteries ఉంటాయి, మనకి అన్చార్జ్డ్ బ్యాటరీస్ ఉంటాయి. అవునమ్మా, కొన్ని సెల్స్ యూజ్ చేసి మనం మొబైల్ వీటిలో క్లాక్స్లో వేసేవన్నీ యూజ్ చేసి పక్కన పడేస్తూ ఉంటాం. కెమెరాస్, కొన్ని డిఫరెంట్ టైప్స్ ఆఫ్ కెమెరాస్కి ఛార్జబుల్ బ్యాటరీస్ ఉంటాయి. మనం ఛార్జ్ చేసుకొని మళ్ళీ పెట్టుకుంటాం, మళ్ళీ ఛార్జింగ్ అవ్వగానే మళ్ళీ ఛార్జ్ చేసుకుంటూ ఉంటాం. సో అలా ప్రైమరీ అండ్ సెకండరీ ఉంటాయి. ప్రైమరీ సెల్స్ ఆర్ నాట్ చార్జబుల్ సెల్స్. దట్ మీన్స్ అవి యూజ్ చేసి వెంటనే మనం అంటే క్లాక్స్లో రిమోట్స్లో వాడేవన్నిటిని ప్రైమరీ సెల్స్ అని అంటాం. సెకండరీ సెల్స్ వచ్చేసరికి ఏంటమ్మా, దే ఆర్ అగైన్ యూజ్డ్ ఆఫ్టర్ కంప్లీషన్ ఆఫ్ దేర్ ఛార్జింగ్ అండ్ వీ కెన్ ఛార్జ్, మనం వాటిని మళ్ళీ ఛార్జ్ చేసుకొని యూజ్ చేసుకోవచ్చు. దట్ టైప్ ఆఫ్ సెల్స్ ఆర్ కాల్ ద సెకండరీ సెల్స్. ప్రైమరీ సెల్స్కి ఎగ్జాంపుల్ వోల్టాయిక్, డేనియల్ సెల్స్ ఆర్ ద ప్రైమరీ సెల్స్ అండ్ సెకండరీ సెల్స్ ఆర్ ఆల్కలి అండ్ యాసిడ్ అండ్ ఆల్కలి అక్యుములేటర్స్ ఆర్ ద సెకండరీ సెల్స్. And next one is EMF of a cell. EMF of a cell and the energy given by a cell is flowing. The energy given by a cell is flowing unit positive charge throughout the circuit. The unit positive charge will be move throughout the circuit completely. One time is equal to the EMF of a cell. So it will be denoted with E. That means the work is done by a unit positive charge completes its one rotation one time. That means EMF of a cell E equal to W by Q. So here he is the EMF. EMF means electromotive force. Okay, and its SI unit is volt. So once I will repeat it. Electric cell is a device which converts chemical energy into an electrical energy. So we have two different types of cells, primary cell and the secondary cell. Primary cells are not chargeable cells and example voltaic and Daniel cells are primary cells and secondary cells are secondary cells can be charged again. Okay, acid and alkali accumulators are the secondary cells examples. So next one is electromotive force. Electromotive force is the energy given by a cell in flowing a unit positive charge throughout the circuit completely one time is equal to the EMF of a cell. That means EMF of a cell E equal to W by Q and its SI unit is volt. And next topic is discussing now. So now discussing the group of cells. We have two group of cells in series combination and the parallel combination. What is the current in series combination in cells and what is the current in parallel combination of the cells? So grouping of cells in series combination, if n cells each of EMF E and internal resistance is R. So series combination we are taking n number of cells, that means 1, 2, 3, 4 n number of cells and each of EMF is E, internal resistance is R connected in series to a resistance capital R, then equivalent EMF can be written as. So this is the series combination of the cells. This means cell means E1 EMF, E2 EMF, E3 EMF and resistance is R1, R2, R3 resistance. This is the series combination. Here we are taking just 3 but we are taking n number of, n means so many. So in this combination the equivalent EMF will be taken as E equivalent will be equal to E1 plus E2 plus and so on En, that will be equal to N times of EMF anamata, N into E. So current in the circuit can be written as I equal to E by R is nothing but a V equal to IR combination. In this I equal to V by R, from this I equal to V, E equivalent, EMF is the voltage, E equivalent by R, R is the R plus R equivalent, R is the resistance, R equivalent is the number of equivalent resistances, R E equivalent is nothing but a N. How many resistors are connected here? In this 3, but we are taking N resistors, then N R is the, then current I equal to NE by R plus NR is the current in series combination of the cells. And next one is the in parallel combination. If N cells of each EMF E and internal resistance R, each EMF E and internal resistance R connected in parallel, then equivalent EMF will be taken as in parallel combination E equivalent will be equal to E. Already know in capacitors we are connected in series R equal to R1 plus R, C equal C1 plus C2 plus C3, but in parallel combination 1 by C equal 1 by C1 plus 1 by C2 plus 1 by C3. Similarly in this case E equivalent equal to E, equivalent internal resistance, this is the parallel combination, these are the EMF, these are the resistances R1, R2 and R3. So in this the equivalent resistance 1 by R E equivalent will be equal to, similarly 1 by C equal 1 by C1, 1 by C2, similarly in this 1 by R1 plus 1 by R2 plus 1 by R3 and so on. How many resistors are there here? N. So then that will be equal to N by R. 1 by R E equivalent will be equal to N by R, then R E equivalent will be equal to R by N. Current in the circuit equal to E, I equal to E by, that means V by R. Here V and E, E by R means R plus how many resistors are there? N, R by N, in that is in parallel combination, then we can write R by N. Once I will repeat it, in grouping of cells, cell is nothing but a which converts, cell is a device which converts chemical energy into an electrical energy. In this group of cells, we are discussing in series combination and parallel combination, and cells are two types, primary cells and the secondary cells. Primary cells are not chargeable and voltaic and linear cells are the primary cells, and secondary cells are the chargeable cells, and these are acid cells are the examples of secondary cells. And next one is the grouping of cells. Grouping of cells, in this we have two types, series and parallel combination. In series capacitor, parallel combination of capacitors we are taking C equals C1 plus C2 plus C3 and so on, Cn in a series combination, and parallel combination 1 by C equal 1 by C1 plus 1 by C2 plus 1 by C3. Similarly in these cells, grouping of cells, in series combination we are taking EMF E and resistance R are connected in series. We are taking here N resistance, but diagram representing 3 resistors only. Here E1, E2, E3 are the EMF, R1, R2, R3 and so on, Rn are the resistors. Then we will get the equivalent resistance. E equivalent will be equal to E1 plus E2 plus E3 plus and so on En, that will be equal to N EMF kavatti, then En EE. Now current in the circuit I can be taken as I equal to V by R. Here V is the E equivalent by R is the R plus NR. This is the current in series combination, series cells. And in parallel combination, if N cells each of EMF E and the resistance R are connected in parallel, then equivalent resistance, then equivalent EMF of cell E equivalent will be equal to E. So equivalent internal resistance can be represented by using the diagram. These are the parallel combination E1, E2, E3, R1, R2, R3. In this the current I will be equal to E. The resistances can be, equivalent resistances can be written as 1 by R E equivalent will be equal to 1 by R1 plus 1 by R2 plus and so on 1 by Rn, that will be equal to how many resistors are there? N resistors, then N by R. That means E equivalent, resistance R E equivalent equal to R by N. Then current in the circuit I equal to E by V by R. Here V equal to E. E by R means R plus R by N in parallel combination. And this is our today's class, cell and the combination of the cells and the different types of cells. Okay, and tomorrow we will discuss the next topic. Thank you.